It's time to make that stairwell. Here I have found reference images of stairwells online. Normally I draw my own content or I photograph my own content, but this one was kind of difficult to find, and I don't think I have the expertise to draw one out unless it was like a fantasy stairwell. So I decided to seek out resources where someone does this for a living. And what I found is a website. I found this company. I believe they're based in the United Kingdom. And on this particular page of their website, they explain their modular packaged spiraling staircase that you can buy and put together for your own building or home. And in here are very good, simple illustrations explaining dimensions and degrees of rotation that we need in order to produce a realistic spiraling staircase. Of course, this is just one kind of spiraling staircase. There are many ways of doing this, but I liked that this company had a simple plan that didn't exhaust, won't exhaust our time in creating it. So I pulled these images off, and I found example images that look very similar to the stairwell that that company is selling. And I've included these in your references download. And some of them have different examples of banisters. The banisters are the vertical columns that hold the handrail. And then the most important ones are the data, the numbers. So looking at this image, what we get are some very important pieces of information. First of all is that there's 13 steps. The second piece of information is that each step has a 30-degree rotation of the total 360-degree circle. Its total diameter, and there were 3 different diameters. You saw this company was selling 120, I'm assuming centimeters, 140, and then 160 centimeters. And then this 86 number, 66, 76, 86, I think that number represents the width of the attachment at the top of the stairwell, which would be this illustration, if I can zoom in on that. I downloaded these as well. So, and this company is saying, hey, our stairwell will fit a round opening, a square opening, no opening, and attach well to the balustrade on the second floor. And the balustrade are the vertical columns that hold up the handrails on the balconies. The other illustration I pulled for you is the riser illustration, anywhere from 21 to 23 centimeters. That's the risers, the distance between the top of one step and I'm assuming the bottom of the next one. It might be the top of the next one. I can't quite tell. This illustration has 2 indicators of what the riser might be. So we'll pick one of those numbers. So we have some really good data here for us to work with. Degrees, dimensions, height, and the 13th step, which connects to second floor. And then visual examples of what the materials might look like. And other things to notice about the imagery. Okay, notice that there is a gap here between the floor and the first step. So the first step's not going to be on the ground. It seems trivial, but important because of the way things are created in Maya, because everything starts at the ground, right? So we want to make sure that the first step is off the ground. That the first cylinder on the center column is on the ground, and it seems to have this extra bit of steel holding it to the floor, probably bolted to the floor. And also notice that it's steel, wood, steel, wood, steel, wood, and so on. And in this example, we've got 1, 2, 3, 4, 5 cables, and then the smooth handrail that appears to be round. And this example has a round hole at the top that's circular, though I don't think that's critical for us right now. We might have time for that. The next one's very much the same as the last one, except this one's all steel, outdoors. Same thing here, all steel. The big difference here is are the banisters. Notice we have 1, 1, 2, 3, 4, 5 banisters per step, and they're level at the ground, or I'm sorry, they're level at each step, but they're at varying heights to accommodate the smooth spiraling up a handrail. So we would need to create that 1, 2, 3, 4, 5 banister rods, get them to match the rail, and then instantiate those all the way up. In this example I like because it has a different shape on the step, with this little profile there. I like that. It has the impression of being hollow underneath, so it's like some kind of hood. Also, the banisters 1, 2, 3, 4, 5. It looks like this fifth one connects, through here, and then of course it has a unique profile where it has a different shape. It's not just a straight line. It seems more elegant, and it has variations. So these is like beaded right there. This is more vase-like right here. This is straight and then around and then straight and round and straight. So it has variation within the banister, giving it more texture, visual texture. And then of course the different materials. We've got wood, some kind of painted steel, and that same painted steel is on the vertical column on the well. So I put these references out here as options and for us to bounce back and forth on in the creation of our own stairwell. I want to make this stairwell. I don't have any other reference of this specific stairwell, so there's a couple of things I'm going to make guesses about. One guess I'm going to make is that all of this is one steel piece. That's one guess. Another guess is that what's hollow on the inside is that if I were to look underneath here, I'd probably see the bottom side of the wood, not steel, right? So it's probably just a steel frame that the wood is screwed or bolted down onto. Another guess I'm going to make is that there's the same number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there might be an 11th one up here, and then maybe 12, 13 down here. So I'm going to guess it's the same number of steps. So I can still use this reference right here. Also, I'm going to use this degree, right, the 30 degrees of rotation with 13 steps, and I'm going to use the same diameter. The rest of this challenge is detailing exactly how I'm going to get this piece of wood to match the inside shape of this exactly, of this column exactly, and also the procedures of creating this profile as one unit. That will be another problem, and we'll start with that one. To get an exact precision of the curvature, I've decided to use cylinders, NURBS cylinders, to start this project. In the attribute editor under the Make NURBS Cylinders, I need to make a guess as to the diameter of the interior column. I'll know more about what that is. As an artist, I am looking at references, so if I'm looking at the sides, the outer side of the step, comparing it to the size and shape of the inside of the step, and looking at that at different views, I can come to some guess as to what that might be. But I can't really make that judgment call definitively until I have more in front of me visually. So for now, the radius of this object is going to be just a few centimeters. Let's start with 10. And that's a radius of 10. Okay, I got to remind myself of that. That's a radius of 10, so that's a total of 20 in diameter. So that's probably too big. Let's go with 5. So the total radius of the center is 10 centimeters. The total diameter is 10 centimeters. Next, I want it to have 12 sections on the total vertical isoparms, 12 sections. And the reason for this is so that I can have 6 on one side and 6 on the other. So select on the inside, isoparm, 1 on the x-axis on either side. And then come up here to surfaces and choose detach. So selecting the positive x side, hide it. Now, height ratio is basically radius. So the total height of this object, if we look at this in, say, the front view here, you can see it's 10 units tall. Each peach block is 5 units, so it's 10 units tall. So that's 2 times 5. So height ratio is multiplied by the radius. For now, we'll leave that alone. Next, bring in a second NURBS cylinder and set the radius of this one to, and we're looking at our reference here, 160 diameter, so the radius will be half of that. So that will be 80. This will have a total of 6 sections. And the reason this one will have a total of 6 sections is because the end sweep will be 30 degrees. End sweep, basically it just compresses all of our isoparms into a 30-degree area, and we want to have 6 sections matching the same number of isoparms on the opposite end. And I mentioned that earlier when I'm lofting and doing boundary type functions. I like to have the same number of control vertices on parallel sides. Next, if we look at this from the top view, we select it. There it is. Turn on the wireframe for the top view so we can see it. We can see that we're pointing off to the side. I'd like to be straight with the x-axis. So select the outer cylinder and rotate it on the y-axis 15 degrees. 15 degrees because it's a 30-degree sweep, so we want to offset it 15. So now it's dead center. Now for the height ratio. It's 160 units tall, 2 times 80 on the radius. I want it to be the same height as the inside. So a little bit of math. So that would be 2 divided by 80, or 1 divided by 40. And that will equal 0.025. And if we enter that in, 0.025 for the height ratio, and look at it in the right-hand view, you can see that it is exactly 2 units tall. So we need that to be 5 times taller. So it's going to expand in both directions from the center. So we want this to be times 5. So 25 times 5 is 125, so 0.125. And now we have exactly the same height between the center and the outer boundaries of this step. And we have the same number of vertical isoparms. Our next step is to loft, and we're going to loft from one isoparm on one object to another isoparm on another object, and loft between them, producing yet another object. The problem here is, if you look at it from the top view, is that this line goes straight to the center of the center column. And if we take a look at our reference and just draw on this for a sec, right here is where that plate connects to the center cylindrical column. It's not actually on the center line, right? So because the center line of the column is maybe like right there, it's not quite connecting there. It's inside a bit. So we need to change what we're doing with this inside cylinder. So basically, just hide the one that you have here and bring in a new one and set up its radius to again be 10. I'm sorry, we did that before. 5, so its total diameter is 10. And its number of sections will be 12. And we'll go with 12. We're happy with that. And then instead of the center isoparm, go one off center. See, those two. And then detach. Detach. And then take that piece and hide it. Now, this piece now has more vertical isoparms by 2, right? So we should have a total of 8. A total of 9. So we want our outer ring to have the same amount. So we're going to set its sections to 8. So now we have a total number of vertical isoparms of 9. Now I'm going to select outer isoparm on this object, outer isoparm on the outer side of the step, holding shift, and lofting. And if the surface is facing the inside, reverse the surface direction. And then repeat that on the opposite side. So now you can see, and I might even be able to bring it in further, but I think I'm going to go with this. This seems fine. And now you can see the actual cylindrical shape and how they would stack on top of each other. And that step is going to be just off center. And that wood that sits on top of the metal will be arced just right following that shape. And we'll probably be able to use that piece that we hid earlier to assist us in creating the total wood shape. Hide this piece one more time. Control H, we might need it later. And make a third NURBS cylinder on the interior. Make it also a radius of 5. And let's start with an end sweep of 30, just like the outside. Although that's not the right amount to fill this gap. Let's take a look at what it might be. Why don't you increase end sweep until you kind of match one side. And it looks like 60 matches that isoparm. So in order to get the other half, we need 120 degree sweep. And then we want to rotate that back into place. So we'll go over here to y-axis rotation. And 120 divided by 2 is 60. So now we have control over the number of isoparms, vertical isoparms. So here we had 9. Do we also have 9 on this one? We want to have, and yes we do, we have the same amount. We have 8 sections on the outside and we have 8 sections on the inside. This will make a great match. Now the loft, we should also have the same number of sections on each side of the loft. Go to the Loft tab in the Attribute Editor and say the section span should be 8. And then same thing for the opposite side. And now we can produce the boundary. So we're going to select each top isoparm holding shift, and then we're going to choose Surface Boundary. And that's going to build our perfect NURBS surface with perfect quadrilaterals. From this surface you can see we could easily convert to polygons, extrude, thicken, and have a piece of wood that matches the inside cylinder brilliantly. Next we're going to work on that profile where it'll be flat and then curve softly in, curve softly out, and then flat again. So let's focus on that part. I'm going to switch my filter to CVs only, components, NURBS CVs only, and I'm going to tag the front end, all of the bottom side CVs, turn off soft selections if you got it on, and I'm going to move that up. And I'm going to move both of these, both the starting and ending CVs up. So I need to get all of these out of the way. And I want this to be exactly at y0. So I'm going to set absolute transform y0. And now we know exactly where they are. And these CVs are the ends, right? We talked about that. Those are the tangent handles. So we want to be conscious of those. And same thing when we work on the sides of the loft to create the shape. So that gives us the taper, but now we want to make the curve. So I'm going to select both lofted pieces, switch to the front view, and set these 3 CVs along the bottom to a value of absolute -5 on the y-axis. So that flattens out the first part, and it softly curves in. And then we want to move these 2 above y0, then drop the 2 on the bottom to y0. And that will straighten out that side. If we take a look at the curve, it's not too bad. It's not quite the right shape. So again, selecting both CVs on both pieces, back to front view, tagging, and modeling a little bit until you get the right curve. And that looks a lot better. Exactly. It looks like at some point the CVs on this got moved. I'm not sure how I did that. So I'm going to put these back to 5 so that the top is nice and straight. So the top should be nice and straight with a nice profile curve along the bottom side. Okay, let's look at our reference and make adjustments. I can see from my reference I have this definite dark line right here. Can you see that dark line cutting across horizontally? And notice how the wood is above each of those dark lines. That's probably because the wood sits on top of where each steel segment comes together. So we can assume that on our next step. So what I'm suggesting is that our cylinder, our pipe, is going to go downwards, right? It's going to go this way. We're not going to model this one in particular, but we'll have to make another one. But point being is it's not going to go up, it's going to go down, because the wood will go up, because that dark line is where the two steps on the pipes come together. I hope that makes sense. It'll make sense as we go. Also, we want the riser to be 21 to 23 centimeters. And assuming I got my numbers and my proportions correct, that 21 to 23. Well, so let's start with 21 and see what that looks like. So let's bring another NURBS cylinder into the scene, and this one will have a radius of 5, same radius, and that automatically gives it a height of 10. So now we need pretty much a little bit more than double that, right? We need 20 to 21. So let's go a height ratio of 4. So that gives us the 10. So 5 divided into 20 gives us 4, right? That's how I came up with the 4 ratio. 4 times 5 is 20. So what is 23, a riser of 23, divided by 5? That's going to be 4.6. Let's enter a height ratio of 4.6. Okay, now I want to move it down. So we know that this is 10 units, and we've just expanded it to 23 units in height. So if 10 units of it are right here, then that means the remaining 13 units are at the top and the bottom. So dividing 13 units from the remaining amount, you have 6.5. So move it down negative 6.5 units. And now we have exactly the riser and the height of the steel step. And going back to the reference and taking a look at it, it feels pretty good. I'm going to say there's probably some, like this distance looks a little shorter than that distance. So if the riser is 23, so let's see, a riser is, 23 would be from here to, I'm going to throw a guess, the top of the step is the riser. So from the top of one step to the top of the next step is 23 centimeters. So the majority, let's say 2/3 of that height is steel, the profile, this distance, and then the other 1/3 is space, closer to the center. Those are the proportions that I'm seeing. And I don't quite have that here in Maya. Yeah, so I'm not quite there in Maya with those proportions. So I have the correct riser, but my proportions are off. So selecting that inside partial cylinder that we've lofted to, and also the interior one. So let's hide this new one we made. So we need this one and the one on the inside to be a little longer. And I've already done the hard work of measuring everything based on where it is right now. I don't really want to go up. Everything else would have to change. So I just want to go down. So I'm going to tag the CVs of these objects. on the bottom side. So I'm selecting from the front view, tagging these CVs. I'm going to move it down. And I'm eyeballing at this point. I'm going to make a good guess because I'm looking for good proportions. So I'm going to unhide this one, toss it onto a reference layer so I can't select it, and then focus on these two pieces. Front view, tag CVs, get this out of the way, and just look at proportions. 2/3, 1/3 proportions, and that does look better. And again, comparing that to reference, that gap, 1/3, 2/3 does look a lot better. I lost a wee bit of the flatness up here and over here in this change. So let's grab CVs again on these objects, selecting these objects, going back to front view and tagging CVs, and I'll set them to an absolute value of -10. So that should flatten out there. And then again up here, just translating those above 0, and then setting them explicitly to 0. And if I'm not mistaken, I got my CVs backwards here. Maybe. No, I don't have my CVs backwards there. I'm seeing things. If anything, I could probably just keep. So get back to CVs. Come on. Get back to CVs and yeah, get that guy. Just pull that down, even that out a little bit, because that will affect when we convert to polygons. There we go. I'll move its neighbor until this side flattens out. Okay, good. Okay, proportions look good. Divisions look good. Dimensions look good. I think it's time to convert to polygons and get the instantiation started. Select the front end surface, 2 side lofted surfaces, and top surface. Convert those. Go with the default control points. Hit apply. Nice. And we can clean up the flow easily with polygons. Select the object that we put on the reference layer, the one that's exactly 23 units tall, and set that one to be converted by control points as well. Good. Before capping the ends of that cylinder, let's run smooth mesh on it. Divisions of 1 exponentially. Perfect. Select all surfaces in the scene. That would be turn off all objects. Whoops. Turn off all objects, and then right-click the polygon icon, NURBS surfaces, selecting all those surfaces, place them onto a layer, and hide them. Go ahead and name that layer too. Go ahead and hide the grid too, right here in the viewport. Good. Let's do a little bit of cleanup on edge flow. Front view. Same idea. Components. This time we want polygon. No. We want polygon vertices. Select both objects on both sides. Just do a marquee. Select through the mesh using a marquee and adjust the flow. If you want to, select rows of vertices and set them to an explicit value. So absolute value on the y-axis, for example. And so here we could choose -6. And I know which value to choose because I'm looking at my numbers right here on my orthographic viewport. And choose an edge flow that makes sense to you. It's entirely reasonable as well to remove these edges completely, correct? Because they are on a flat surface. Control Delete. That simplifies the problem considerably, doesn't it? Now later on we may need to add in edges in order to support painting textures, but for now it does simplify the problem quite a bit. Do the same thing on the other side. Now spend your time changing the shape of the profiles components with poly vertices front view, and just tag both objects. Tagging both objects and manipulating vertices, controlling the curvature with polygons. Ultimately with the goal of either subdivision surfaces or smoothing. And now it's really easy to set things at explicit values. We don't have that double CV thing getting in the way. Let's clean up where divisions are on this center cylinder as well. Let's begin by simplifying it by removing edge loops. Control Delete. Then let's set this one here to be at an absolute value of -10 like we did the vertices on the steel part, on the front steel part. So -10. And then we can remove this row of vertices there. So that really simplifies that problem as well. Now let's take a look on the interior and see, do we satisfy the problem of having enough vertices here to support on the inside of the cylinder? And it looks like it does not, because I did not convert the original surface that was on the inside, creating this boundaried surface on the top. That's okay. Eventually this is all one piece of steel. We're gonna fake weld that these things are welded together, the pipe and the plates. So I have basically 5 edges on the inside of the cylinder, and I have 11 edges that I need to connect to across the top. So what I really need to do is smooth this object one more time. So I'm going to remove this edge loop down here temporarily so that I don't get extra horizontal divisions. And then I'm going to run smooth on this object one more time. Same settings of 1. And that should give me the amount of edges that I need, and take a moment and count them. Yeah, it gives me exactly the edges that I need. And they're not quite in the exact same spot, but I think it'd be okay to move them around a little bit. Another way to approach this problem, and I've been thinking about this, is to take that inside NURBS piece that we created a while ago and convert that as well. And then from that one, let's put the NURBS surfaces on a layer here and hide it. So here's the polygon object. Turn everything back on, and everything matches up perfectly, right? So we could combine all of these pieces together into one piece, and that would be one solid piece, even go through the process of thickening it. And then we could make connections to the cylinder via Boolean or via some other process, welding it, for example, or just combining, or even shortcutting it if we really need to and just clip the two things together. I like this solution here better because at least I get the matches to come together. So I'm going to flip the normals on this piece, reverse surface normals, there we go, so everything's pointing at me. I'm going to bring all of these pieces together, and oh yeah, let's remove that and that so we have a good clean match. Select all of those surfaces, select all of these polygon objects and combine them into one mesh. Then merge any remaining vertices. Be sure to do that with a very low tolerance. So that should capture everything that sits on top of each other. Tap number 3 just to confirm that things did come together. And it looks like we're good. We might have just a small problem on the corners, but it's a very, very, very small it's really nothing. Very small problem on the corners. Okay, not a big deal because we're going to attach to that cylinder. Then unhide the cylinder. So now I've got my cylinder back, and it still has those increased number of divisions. So we're still really close to getting those to come together. So let's focus on getting these two pieces to come together as one solid piece. Okay, I have a plan of action to get these things to come together. First, take this edge loop right here on the vertical cylinder. You if you followed me exactly, you will have this one edge loop, set it to -10 on absolute Y, so it lines up perfectly with the bottom side of our steel plates. Then look at the object right about from this angle, select two faces that I have selected at center, grow, not grow your selection, but add to your selection. So just hold Shift and add till you are like one polygon out, right? Just exactly the same selection I have right here. Delete. Looks like I missed one. Delete. There we go. Okay, now on the inside of the steel plates, this one, select everything here, hold Tab, and just click and drag. Haven't been using that much, but this is really cool. Discovered it midway through recording this. Holding Tab, just click and drag. It's basically raycast selection. Extract this. Extract it. Okay, select it, this new object, this one object, flip it, reverse the surface direction. Take these pieces, these two pieces, and now bring those two pieces together into one object, combine, combine. Delete construction history, remove this edge loop and that edge loop, Control Delete. And seeing this now, on second thought, I think I would rather just delete all of these faces along the bottom inside right there. Take those out as well. Select the vertices on the bottom side of the inside and set those to the absolute value of what? Let's see here, 5, 10, 15, 16, 17, 18 units. So -18. Okay, so now that's the full length. And then just to simplify this, I know I've asked you to add this edge so many times, but Control Delete it one more time so that when we choose to append to polygon, we can just stitch these sides together super duper fast like that. And then repeat that. Hit Y to repeat and then hit Enter to finish. And now we've got the inside of the cylinder matching the plates exactly. And now we can add those edge loops that we need. So I'm going to get multi-cut one more time. Make sure I'm going to make sure that edge flow is not on. So I'm holding Shift and Control and right clicking. Make sure edge flow is not on. Control, click, and then tag all those vertices and set them to absolute value -10. One more time. Good. Now that all lines up on the inside, lines up along the bottom, looking. So we still don't quite have it yet, right? Because if I were to stay just the way I am and combine these things, it's basically the same as having a non-manifold mesh, just like a strip of polygons extruded off of an edge. That's not good enough. What I really need to do is thicken this piece, and then at the boundary where the thickened part matches, extrude this section. So let's start with the extrusion so you can see what I'm talking about in profile. So if I take, oh yeah, hold Tab. There we go, cool. Cool. If we take that and extrude it, Control E, and set that to, I don't know, let's do whatever might look right. Whatever it lets me do. So let's do 0.25. Okay, so let's just imagine that this polygon here and the one across the top, yeah, that minus this minus that. So that selection is the thickness of the steel plate, and we can make it thicker if we need to, but let's just imagine that that's what the thickness is. That's what I need this to be thickened to. So here we'll Control E, thicken this. And let's see if thickness is, yeah, and we want to thicken inwards, negative 0.25. Obviously not thick enough. That would be very, very thin. And looking at the reference, I really don't have a good image of me. I see a highlight right there. It's probably thicker than that. That's basically 1/4 of a centimeter. It's not very thick. It's got to be thicker than that. So here's what I'm going to do from this point of the analysis. Select this cylinder, go to Hypergraph Connections. Select the last extrusion that I did and delete it. Okay, so that should remove the extrusion we just created on that. Yes. Then I'm going to continue with the extrusion I have on this one. I'm going to hit T on my keyboard for Transform Manipulator and then select the Poly Extrude operator. That will automatically bring up this window back. Let's set this to negative at least 1/2 centimeter. So negative 0.5. Yeah, at least 1/2 centimeter. That's good. All right, now that we know how thick we need it to be, let's insert edge loops. Let's insert one there. Select that whole edge loop and set it to the same position. So we know that's 1/2 a unit thick, right? So that would be 4.5, because we know the top is at 5, 4.5. Perfect. And then same thing over here. Insert another edge loop and set this edge loop to negative 9.5, because we know the bottom is negative 10. Good. And that should at least connect to I don't know if we really need that one there, do we? We really don't need that one down there, do we? All right, well, let's remove that. Okay, moving right along, we've got an edge on the interior here for us to work with. We could edge slide that. We could edge slide that one over a bit, and that should make it easier to make a connection. Do the same thing on the other side. Edge slide it over. Good. All right. I think we've got a really good setup here. So let's just hide this one for a moment and take polygons on the inside from here to here. Shift double click. Shift double click. No, that's not going to do it, huh? Okay, that did. And delete. And delete. Good. Nothing else is deleted, right? In order to connect across the top, we first need to fill this object's holes. So go to fill hole. Good. Now we can hide the step for a moment. Let's hit Shift P to make sure it's not inside any hierarchy. In fact, let's delete construction history for both of these pieces, and then hide the step, and delete those pieces, and delete that one. And turn your heads-up display on so you can see how many faces you have selected. Good. And delete that one. Good. Now we can make the connections. Great. So I've got the hole cut in order to attach the step, and everything matches up really, really well. I'm going to go through with a combination of edge, bridging, target welding, everything you've seen before. I don't think you need to see this part. Oh, but one thing you should see is that I am missing one edge loop on the top of the step. That needs to be inserted there, and that edge loop should be set also at an absolute value of 4.5. Yep, and now I've got an edge loop at 4.5 all the way across. matching the top up here perfectly. And now I can perform my connections. Of course, first you have to combine the objects. That helps. And before I do any target welding or anything, I will first attempt to merge. And see how many things did not get merged. So we got a couple on the side that did not get merged. So I will target weld those. On the inside I have an extra edge I didn't anticipate. So I'm going to target weld. Okay, got it. And then target weld not to the corner, but to the side. Just off to the side. So there's a triangle there, but don't put the triangle on the corner. If you have the same situation I have. And you probably do. Okay, so that makes a clean connection for me. I think I got everything. Oh, it looks like I still have a couple of floating ones missing. You can see these big arrows when turning on subdivision surfaces. Something's not quite right there. Yeah, selecting this one here. It says it looks like one, but it says there's two there. So I just selected both of them and chose merge. Just the regular merge. And probably the same thing over here. Yeah, it says two. Merge, and now I've got one. Okay, those are clean connections. Other than the crazy n-gons at the poles, these are good connections, and now I'm going to spend time adding supporting edge loops. Okay, here I have done two extrusions, 0.25 extrusion, 0.25 extrusion, then a third extrusion towards center, arbitrary distance on offset, and I'm going to leave the n-gon there. Then I'm going to add a supporting edge along the bottom. For the bottom, I'm going to select all the polygon strip on the bottom and then convert that selection to edges. Convert to edges or Control F10. Then I'm going to remove the edge loop, so Control Shift Control double click. There we go. So Control click one, Control click a neighbor. That removes all of the cross edges along that. Keep the corners up here, keep the corners. And we're going to perform a bevel. Continue adding edges to your selection. Okay, here's my selection. It's basically the perimeter of the entire step, including corner cross edges. And I did not add this top part here where cylinder and step meet. I don't know if I want to just yet. I'm going to perform the bevel once and see if it's necessary. Two segments, a fraction of 1.0, wide enough to see it. And then I'm going to tag this area and frame it up and get close in here. So there's a bit of folding going on here. Tag a vertex. Let's translate with edge slide. Okay, there we go. Not too bad. 1, 2, 3, 4, 5, 6 edges coming to that corner. That's something we can deal with. Looks like we also have 1, 2, 3, 4, 5, 6 at the bottom down here. And we'll have to use some of our tricks from earlier to deal with that. We could use immediately an edge loop support across the bottom. And I think doing that as a straight line. So I'm going to multi-cut, holding shift, and just add that as a straight line. And then tag that and just tuck it in closer as a supporting edge loop. I guess let's do that one more time. Closer. Yeah, okay. That should do it. So as expected, the outside corners look really good, even with subdivision surfaces. It looks really good and clean out here. I don't intend to use sub-Ds with this setup. I'm beveling the edges so that I don't have to use sub-Ds. But the option is there. The option is there to use subdivision surfaces. I just have some 6-edge poles to clean up on tops and bottoms at the connections, and that's it. I'm placing a really tiny bevel down here. So like 0.025, a really tight bevel down here, so that if I choose to use subdivision surfaces, it will hold its form. Also sets me up nicely later on if I want to slice this up for better painting, if I use subdivision surfaces. If I'm not using subdies, and I don't really want to, then I just want to have a bevel down here to catch a little bit of light so that I can see that seam from one section to another. So here, what I'm doing is I've selected the vertex that's at the point of 6 edges coming together, and I chamfered it. Then I'm going to use the multi-cut tool to make the appropriate connections. And I'm going to multi-cut straight down 50%, all the way to this corner. And then it looks like I have just one more polygon to deal with. Right there. Right there. Whoops. Let's undo that. Right there. And then, there's a triangle here, but we could easily take that and Control delete it. And now we should have 1, 2, 3, 4, 1, 2, 3, 4, so on, count it. But take a look at it. Do a little edge sliding, get things out of the way, clean it up. Looks really good. Maybe surface sliding. Try to do minimal vertex moving, otherwise it'll hurt the precision manufactured look of it. I'm just going to toss some material on it so I can study that specular highlight and see how I did. Yep, not too bad. Not too bad. Really not noticeable. Now I can fix the others. Here I've softened the edges so that those bevels look decent even without subdivision surfaces. Got one half looking pretty good, so I'm going to go to the top view and select the not as good half. Confirm my selection. Delete it. Mirror it over using any of the techniques we've covered. Alright, place this new polygon object onto its own layer and name that layer. And delete construction history and name the object as well. Unhide the surfaces that you have put on a layer and take that top one and convert that one more time. And that one's going to become our wood piece. Extrude it and thicken it. Let's go with a value of 1 centimeter, or let's go with 2 centimeters. Let's look at reference to get an idea. Hide my surfaces, show my mesh, and looking at that thickness right there, looking at my reference, 2 centimeters seems good. Proportions. Good proportions. That will change our riser to be 21 centimeters because this is 2 centimeters thick, clipping off 2 centimeters on our total cylinder height. So our riser is going to be an actual 21. That's fine, according to the documents that we saw earlier. Okay, bevel all the perimeter edges, including the corners. Fraction 1, segments 2. Set the mesh to have softened edges. Apply a material. For this, use Fong E and get a brownish color. With your object named, put it on its own layer and unhide the metal, and let's apply a new material to that. Blend. And if you wish to I guess ultimately if we're going to render with mental ray materials, we could do the material X pass. So let's stick with that if we're going to stay with mental ray. And we could say metal material, check mark that right there. Or we can go to one of these presets in here and pick one of the metal materials. But I don't think they have one I want. It's all shiny, really shiny stuff. Chrome and copper. Or maybe satin to metal. That's probably better. Same thing for the wood. I'll switch to material X. Make the reflectivity glossy. Delete construction histories. And then come up here to the hypershade. I'll show you a new tool in here. And come up here and choose, yeah, right here, edit. Delete unused nodes, and that will wipe out any materials we're not using. There we go, good. Okay, group this as a single piece, Control G, and let's put the pivot point of this piece at the bottom of the cylinder so that when we define how it offsets upward, we are exactly on point. So let's make sure that this bottom part of our object has been poked so that we have a vertex to snap to. Selecting one or both of the pieces and hitting the up key, hitting W, holding down the D key or just tapping D, and then move it and snap it to vertex, hold V, and snap to vertex to move the pivot point there. Okay, so that's the pivot point of our group. We know we want 13 of these, so that's easy. So we've got one, we can go for a total of 12. We want instances, but I'll tell you what we want to do one more time is take both pieces inside the group, inside the outliner, and group it again. Okay, double group, double group. This will be an advantage for us later. Go with the copy option, so we're going to instantiate the group's transform node. The pivot point location of this second group is not as important. The pivot point of the first one is used for positioning. That's more important. Name your groups. I named my top level group step group. I named my instanced group step group instanced. For the step group, set the local space set local space pivot X column local rotate pivot to 0. If it says anything other than 0, it should say, if you have exactly what I have, negative 18 units. And I'm basically centering the pivot to the world. So it should say 0, 0, 0, 0 right here in the X column for local rotate pivot, local scale pivot. So our riser is 21, but the actual length of this pipe is 23. So set the translate Y to 23. So for our degrees of rotation, we have 13 steps. So what we're going to do is divide 360 by 13, and that's going to give us 27.69. But what we're looking for here, then we can come back to that number in a moment. What we're looking for here is a crisscross where, if we look at the reference, where'd that go? That the one of these banisters cuts through. You see, so one of them, the corner of one above it is just overlapping the corner of the one below it, and it's got this little column running and connecting, and that's how they stay connected. Or they stay connected because they cantilever via a weld with the steel, but visually they're staying leveled with this little overlap here. So the actual rotation isn't going to be quite what we expect it to be mathematically. So here we've got the math of 13 steps divided into 360 is 27.6923, but it might be a little bit lower than that, and we can test it by bringing in just a simple object, polygon object, cylinder, and just tuck it, like, there on the corner where one of the banisters might be. Okay, it's not exactly where it will be, but let's just say that that's where it might be. Then we'll take the group, upper level group, step group for me, and we'll run these numbers. So where's that calculator again? 27.69. And we've got 1, so for 12 more, and hit apply. Just want to turn the wireframe on so I can see it too. And notice how we get an overlap, but it's really close on the corner there. I guess we could go with this. We really could be going. I'm kind of thinking I'm going to go with this, but it's tucking the corner. So if you want a little bit more space on the edge there, and we're really cutting it close, then you could drop this down to like 26.8, 26.7, 26.6, and just get a little bit less rotation, but a stronger overlap. That is looking pretty badass, isn't it? That's cool. I love it when you finally get to the iteration step.